So Swift Engineering is started out as a race car company founded in 1983. And back then we were building strictly race cars. We have a small group that works on aerodynamic design, aerodynamic analysis of both ground and air vehicles. And Computational Fluid Dynamics, or CFD, is a tool that allows us to essentially model the aerodynamics of a vehicle, whether it's ground-based or an air vehicle like an airplane, in the computer. So it's kind of like a wind tunnel in the box. And so we've partnered with Platform Computing to help us manage our cluster, and with Cray on the hardware side, and we use Metacomp Technologies CFD++, which is the flow solver that we use to analyze the flow over the vehicles.
The reason we went with Cray and Platform Computing was that they provided a cohesive solution that allowed us to maximize our throughput and minimize the amount of system administrative tasks. Because clusters are known to be a little bit difficult to manage, the combination of the two gave us reliability and maximum productivity.
You know, from the standpoint of what we want to do in solving these computational fluid dynamics problems, the larger the problem gets, the more computer horsepower we need.
The CX1000 unit is 18 nodes and essentially 144 cores. On it we run CFD++ for most of our CFD analysis. The benefits of having the two, CX1000 and the Platform HPC, it allows us to manage 144 cores seamlessly with minimal user interaction.
And that allows us, you know, from a cluster management side of things, again, to make things very easy for us to manage the system so that we're spending the time on solving the problem and not on managing the system itself. You know, if we're looking at rapid prototype development of new vehicles and the customer is you know, anxious to get their product out first before their competition, we typically have a very short design cycle. But there's so much more that we can do now. Again, we can go through so many more design iterations, and the more you can iterate on the design up front in Aero, the more you can optimize your solution and get a better product for your customer. And so that's been the biggest return on investment for us, is just the ability to turn these jobs around quicker, to be able to work on much bigger jobs as well. If we decide that, you know, we want to look at the detailed flow in certain areas and we really need to increase the grid size, we can solve those problems in-house now.
Recently, we've removed our wind tunnel to make space for additional manufacturing capabilities. And we felt that it was justified because the solution that we have now in CFD can give us just as good accuracy as most wind tunnels available.
So with Platform HPC, if we need to expand our cluster from a hardware standpoint, it's as easy as essentially as bringing in that new hardware, adding those nodes essentially to the existing distribution of Platform HPC, and to take advantage of the ease of cluster setup and then management within HPC.
Platform HPC has proven to be both reliable and very supportive. For most of our applications, Platform HPC has seamlessly helped us, but then in the few cases that we do have a hiccup, Platform support has been able to help us and service our needs very quickly.
We're extremely pleased with the solution that we ended up with Cray and with Platform. The ability to be able to solve the problems that we need to without spending time managing the system has just been wonderful. We've been able to increase our throughput, we've been able to solve much bigger jobs, and we don't have to worry about how we're managing the system. All we have to do is worry about what we need to do to design the product and make that product better.